Department of Information and Communications Technology shall be the primary policy, planning, coordinating, implementing, and administrative entity of the executive branch of the government that will plan, develop, and promote the national ICT development agenda. This is under the Republic Act 10844. And of course, the banner program, one of the banner program of the DICT is the free Wi-Fi for all. So by virtue of RA 10929, free Wi-Fi for all aims to provide access to free access to internet service in all public places throughout the country so as to promote knowledge building among citizens and enable them to participate and compete in the evolving information and communication age. So this program began in 2015 and it was signed into law on 2017. So just a quick run through on our house rule. Number one, make sure your mics are on mute. It's not that we don't like to hear from you, because on our second house rule, we'll make sure your thoughts will not be left unheard. But may we request for your questions to be asked only on the chat box. Our resource speaker will be allotting time to answer your questions and at the end of this discussion. And number three, for everyone who registered, fill up the attendance sheet. So the link is provided in the chat box. Also, webinar codes will be flashed at the middle and at the end of the session. So make sure you'll get the 2 codes because these are required in claiming your certificates. And then you can watch the replay of the webinar on the Free Wi-Fi for All YouTube channel. So with that, let's all welcome our resource speaker for today. So he is a Cisco Certified Academy Instructor, a Huawei Certified ICT Associate, and a Microsoft Technology Associate. He has been a computer instructor for 7 years now and is currently the Information Technology Program Chairperson of Batangas State University, JPLPC Malvar Campus. Since receiving Cisco certification, he has been handling Cisco 1 to 4 courses for both information technology and computer science programs. Under the CHED K-12 Scholarship for Graduate Studies grant, he is a few units shy of earning the degree Master of Engineering with specialization in computer engineering at the Technological Institute of the Philippines. So guys, without further ado, Engineer Erwin F. De Castro. Sir Erwin, take it away po.
Okay na ba? Thank you for that wonderful introduction, Ma'am Chris. Okay po ba yung audio ko?
Yes,
check
sir.
Before I start. Ayan.
Loud and clear, sir.
Good afternoon, everyone. So thank you for attending this webinar entitled Introduction to Routing and Switching Using Cisco Devices. So to give an overview on this topic, so we will be discussing most of the important topics on Cisco 2, which is the routing and switching. So basically tinuturo ko siya ng isang buong SEM, but since we're having a limited time, pinili ko lang yung mga important topics to discuss. And these are the topics that we will be discussing for today. So we have the routing concepts, the static routing, dynamic routing, switch networks, switch configurations, and VLANs. So let's start for the first topic, which is the routing concept. So specifically, we will discuss the router initial configuration, the routing decisions, and the router operation. So before we start, let us first review the OSI model since Cisco 1 hanggang Cisco 4, so lahat ng networking kailangan may sa puso natin yung OSI layer, hindi dapat natin siya makalimutan. So yung OSI layer natin, we have 7 OSI layers. So application, presentation, session, transport, network, data link, and physical. So I hope everyone are familiar with this OSI layer. So every OSI layer has their own PDU or what we call the protocol data unit. So ito yung nagiging output ng every layer sa OSI layer natin. So on this presentation, we will focus on, since we are discussing routing and switching, we will focus on the router and switch. So we should always remember that router is a layer 3 device. It falls on a layer 3 device, which is on a network layer. And ang binabasa niya is yung packets. And switch naman is a layer 2 device, and it reads yung frames natin. So with that, ibig sabihin, the router, ang ginagamit niya in decision making is the IP addresses, and yung switch, ang ginagamit niya is yung MAC address or yung mga physical addresses natin. So that's the OSI model. Kailangan natin tandaan that router is layer 3, switch is layer 2 device. So why do we need routing? So bakit po ba natin kailangan ng router? Kasi kung walang router, ang kaya lang nating ma-reach na network is yung local area network lang. Or yung tulad nitong sa figure. So this, yung mga may circle, yan yung mga routers natin. Without your router, you cannot reach from different networks. Ang kaya mo lang ma-reach is yung same network mo, because the main purpose of a router is to connect one network to another network. Isa pa sa primary function niya is to determine the best route. So router din yung nagde-determine kung saan niya ipa-forward yung packet. So siya yung nagde-determine kung alin yung pinakamagandang daanan ng packets para makarating siya sa destination ng data natin or ng traffic. So paano ba natin malalaman kung ang ang dalawang IP address ay on the same network or hindi? So I know you already know this IP addressing, so i-review na lang natin. So ang i-discuss lang natin or ang gagamitin natin sa mga examples natin are all class full addresses. So ibig sabihin, sumusunod siya sa class IP class table, yung class A, B, and C. So para malaman natin kung anong class ang isang IP, titingnan natin yung first octet ng IP address. So for example, this IP address 192.168.1.1, yung 192, yun yung first octet niya. Now, para malaman mo kung anong class siya, pag yung first octet niya nagre-range from 1 to 126, therefore siya ay class A. And this is the default subnet mask. If the first octet of IP starts from 128 to 191, it is a class B address, and this is the default subnet mask. If your IP address starts from 192 to 223, yung first octet, it is a class C address, and this is their default subnet mask. So, doon natin malalaman kung anong class siya. Ngayon, the question is, how do we know if two IP address are on the same network? So, kung based sa class nila, kailangan mag-match yung mga network bits nila para masabi natin that they are on the same network. Pag same network, hindi natin kailangan ng router. Pagka different network, doon na natin kailangan ng router. So for example, we have two IP addresses here, 192.168.1.1, and the other one is 192.168.3.1. Now, if we look at the IP address, it's 192, so therefore it is a class C address. So sa class C daw, 3 octets is yung network bits niya. So dapat yung first, second, and third octet niya parehas. So 192.168.1, 192.168.3. So hindi sila parehas, therefore they are not on the same network. Kung gusto mong mag-usap yung dalawang IP na yan, kailangan natin ng router because they are on a different network. So we have another example here, 192.168.1.1 and 192.168.1.2. They are on the same network kasi class C din siya. Parehas sila, 192.168.1, 192.168.1. So they are on the same network. So ibig sabihin nun, kahit walang router, so switch lang, kaya nilang mag-communicate. So yun yung purpose ng router. So routers are also computers, are considered as a computer dahil ang computer, di ba meron po tayong processor, may operating system tayo, storage devices like RAM, hard drive. Ang routers, ganun din siya. Meron siyang processor, may operating system siya which is yung Cisco iOS. May mga storage device siya na volatile and non-volatile like RAM and ROM, wherein doon natin ini-store yung mga running configurations natin, startup configurations, and so on. So by the way, since ang Cisco devices yung dinidiscuss natin, yung mga configurations natin will be Cisco commands. So hindi lahat ng router pwede mong i-configure using the Cisco commands. Like on Huawei, yung mga Huawei devices, iba naman yung commands or iba yung syntax niya. But the idea or yung process are the same. Kasi yung process and ideas are may sinusunod silang standards. So this is an example of a back panel ng isang router. So we have here yung mga LAN interfaces. So wherein kinoconnect natin yung mga LAN connections natin. Meron din siyang USB ports for updating our operating systems or informations. So yung operating system, dito siya nakalagay sa flash card slot. Para siyang malaking SD card na yun yung parang hard drive niya ng routers. Doon natin ini-store yung operating system ng Cisco devices. We also have console port. So yung console port are ports na ginagamit para ma-access natin ang Cisco device, yung CLI niya or the command line interface. We also have here yung mga HWIC slots. So para magkaroon ng serial interface ang ating Cisco routers. So the primary function of a router is to determine the best path to send or to forward packets. So yun yung pinaka-primary function ng router, to determine the best path papunta sa destination. So routers are using a routing table like a map to discover the best path to a given network. So yung mga routers natin, nag-build sila ng map para makabuo sila ng list of routes na kung saan doon natin makikita kung alin yung mga network na kayang puntahan ng router. So we can use the show IP route command ito sa loob ng privilege exec mode, yung show IP route command para lumabas yung routing table natin. So ito yon, ito nasa baba. So default gateways. Ang default gateways, so I hope familiar tayo sa default gateway. Ang default gateway po is the IP address ng interface ng router. So para saan ba ang default gateway? Sabi natin kanina, diniscuss natin that ang router, kagagamitin natin siya if we are trying to connect to the other network or sa ibang network. So for example, meron tayong bahay tapos may gate. Kapag kakakausapin mo yung nanay mo na nasa sa loob ng bahay mo, hindi mo kailangan lumabas ng gate. Tama po ba? Kasi nasa isang network kayo. Pero pag inutusan ka ng nanay mong bumili, so yung tindahan nasa labas ng bahay, kailangan mong dumaan sa gate. Kasi ibang network na yung bibilhan. So parang ganun yung ibig sabihin ng default gateway natin. So the default gateway, ginagamit natin siya if the destination na gusto mong puntahan are outside your network. So to show you an example, I have here a packet tracer activity. or topology na ginawa ko na siya. So yung router natin, since ito yung dadaanan natin palabas ng network, ito yung lalagyan mo ng default gateway, di ba? Parang obvious naman na ito yung daan mo para makalabas. Kasi ito yung sakop ng LAN natin, di ba? Ito yung local area network mo. So kung ang i-communicate mo is within here lang, hindi mo kailangan ng default gateway. So to prove that, maglalagay tayo ng IP address sa device na to without putting a default gateway. So I will put 192.168.10.10. So that's the subnet mask. So wala akong ilalagay na default gateway. And on the other device, so 192.168.10.20, wala din akong ilalagay na default gateway. Pag nag-send ako ng traffic, successful siya. Pag sinimulate ko, nakarating naman siya. Dahil wala akong same network lang yung destination. Diba? So, hindi ko kailangan ng default gateway. But, if I will try to connect here, so, try natin, palabas ng network sa server, so, mag-fail siya. Pag tinignan natin sa simulation, delete ko lang to. Deletein natin. Pag tinignan natin siya sa simulation, hindi agad siya nakakaalis. So, failed agad. So, unang-una, dahil patay yung link na to and dahil wala siyang configured na default gateway. So, yun kasi yung purpose niya ng default gateway. Ayan. So, how do we enable an IP on a host? So, kung gamit mo is a Windows device, so you can just go to your control panel, punta ka ng network and internet, network sharing, and click the change adapter settings. So, since I am using an Ethernet cable, so Ethernet and then properties, hanapin lang yung Internet Protocol version 4 and lalabas na yung option mo. So, in obtaining an IP, we have two ways. We have static or statically obtaining an IP. Ibig sabihin, pag static, ito yon. Ikaw mismo yung maglalagay ng IP address mo. But the most common na ginagamit is yung dynamic wherein kumukuha siya ng IP sa isang DHCP server or the Dynamic Host Configuration Protocol server. So, doon siya kumukuha ng IP address automatically. So, yun usually yung ginagamit natin, yung DHCP. Ayan. So, how do we access naman the routers? So, sa packet tracer kasi, if you want to access the router, you just click it and then go to CLI. Diba? Ito na yan, yung router. Pero sa totoong buhay, hindi mo pwedeng i-click yung router. Diba? So, para ma-access mo yung router, kailangan mo ng device na may serial port or di kaya USB port. And kung serial port ang gagamitin mo, you need a console cable for that. So, console cable, yung kabilang dulo niya is sa serial port RS-232 and then yung kabilang dulo sa console port. Or you can use a USB to RS-232 adapter or a USB type A to USB type B kasi maliit yung USB port na console ng router. After that, you need an application like TeraTerm or PATI. So personally, kapag ka naglalaboratories kami, ang ginagamit ko is PATI kasi doon na mas madali siyang gamitin. So you just use the PATI and then i-input mo yung serial connections and then automatic ma-access mo na ang isang router. So dito, pagka ang ginagawa ko sa class ko, since hindi ko siya pinapa-click, sinasanay ko sila na sa device, kukuha sila dito ng console cable, this one, yung light blue. i-connect mo siya sa RS-232 ng router papunta sa console port. Yan. And then, punta sila ng terminal. Click OK. And then, ito na yung router. Diba? So, dito na sila magko-configure. So, parang simulation din siya kung paano talaga i-access yung mga router natin. No. Yan. So, basic router configuration settings. So, yung nakikita nating mga commands like itong enable secret class, line console 0, ang tawag namin dito is yung house rules. Ibig sabihin, every devices, kailangan mo siyang lagyan yan for security purposes, for remote access. So, almost lahat ng networking devices na kinoconfigure mo, nilalagyan yan. And configuring the IP interface. So, since yung default gateway nga natin, for example, this one sa taas sa PC1, ang default gateway niya is itong G00 ng router 1. So, kailangan i-configure mo siya as your default gateway. Diba? Kailangan yung IP address mo as default gateway, mailagay mo dun sa interface na yon. So, to do that, dito na lang natin siya i-discuss sa packet tracer. Delete. Ayan. So, on this topology, kaya na nating i-analyze na ang default gateway ng device na to or ng LAN na to is itong device na to or yung link nito ng router. So, usually, ang ginagamit nating default gateway is the first usable IP address ng network natin. So, ito yung network address natin which is 192.168.10.0. We all know that 10.0 is a network address. Therefore, hindi siya pwedeng gamitin sa host. Hindi mo siya pwedeng ilagay sa host. .0. Hindi siya tatanggapin kasi siya ay isang network address. So, balik natin. 10.10. Ayan. So, the first usable, which is 10.1, yun usually yung nilalagay as a default gateway. So, paano siya? Unahin natin yung house rules. So, when configuring a router, we use the enable command para pumasok siya sa global configuration mode and then configure yung terminal line. Configure terminal. So, kailangan nasa loob ka ng config. Router config. So, ito na yung configuration mode natin. So, dito na tayo maglalagay ng mga commands for the router. So, configurations. First things first is to change your host name. So, let's say this is R1. We use the command hostname R1. So, ito yung hostname niya ngayon, router. So, after that, mag-iiba na yung hostname natin into R1. So, importante siya for tracing, for documentation purposes, para malaman mo kung anong router ba yung currently kinoconfigure mo. Especially kapag sobrang dami na ng routers na involved sa network. Next is, you put a password dun sa enable. Kung mapapansin natin, nag-input ako ng enable, wala siyang hininging password. Diba? Pagka naglagay ako ng enable secret, yung enable secret, enable, it's either you use password or secret. The difference, password is hindi siya encrypted, ang secret encrypted siya. And so kaya we use enable secret, let's say class. Class yung password natin. Ibig sabihin, pag nag-type ka ng enable mamaya at humingi ng password, ang password mo doon ay class. Ayan. Next, you use a banner MOTD. Ibig sabihin, yun yung header na lumalabas pagka in-access mo siya. Let's say banner MOTD and then any sign na nag-indicate ng start and end. Yan. So, usually, ito yung ginagamit ko. Let's say, authorized access is prohibited. Ayan. So, parang ito yung lalabas na message kapag ka in-access yung router. So parang header or banner na makikita sa router natin. So ito yung pagkakasunod-sunod or kahit hindi siya sunod-sunod na pag-entry ng house rules. And then we use a password for line console 0. Ibig sabihin nito, kapag ka in-access yung router using console port, ito yung hihingin niya na password. Password, let's say Cisco, log in, and then you exit. So pag wala tayong nilagay na command na to, kapag ka may ibang tao na nag-access sa router natin using console cable, hindi siya hihinga ng password. So, di ba, that's a security risk. Kaya laging nilalagyan natin ng password yan. And we also have the line BTY. So, since it is a router 04, yung line BTY naman, so, pwede kasing pag-access ng router using cable or using remote or using telnet or SSH, which will be discussed later. So, kapag ka-remote, ito naman yung gagamitin. So, same, password Cisco, login, and exit. Ayan. So, ito na yung house rules natin. Makikita natin siya sa do show running config. Ayan. Lalabas din yung mga running configuration natin. So, ito pa lang yung nalalagay natin. The banner MOTD, login. Kung makikita natin yung password, naka-plain text siya, di ba? Cisco. So, that is security. Di ba? Parang hindi siya secured. So, pwede natin ilagay yung command na service, password, encryption. After that, to show run, makikita natin that the password is already encrypted. Ayan. So, yun yung purpose ng service password encryption. So, now we're done sa house rules. We need to configure now the default gateway, which is the Gigabit Ethernet 00. So, paano siya? Interface, Gigabit Ethernet 0-0. Ayan. And then you put your IP address here, which is the 192.168.10.1. Question mark. Pag hindi mo alam yung command, you use the question mark. IP address. So, you need to use the ABCD command. Or ibig sabihin is yung first octet, which is yung IP address mo, 192.168.10.1, followed by your subnet mask, which is 255, class C siya. So, ito yung subnet mask natin. And then, kung mapapansin natin, naka-ready yung link, therefore, it is turned off. So, naka-off pa siya. So, paano buhayin ng isang link? No shutdown command. So, to shutdown, shutdown. Kung gusto mong buhayin, i-counter mo lang yung command using a no command. So, no shutdown command is used. Ayan. So, ngayon, di ba, may gateway na tayo na configured. Now, lagay naman natin dito yung default gateway, 192.168.10.1 and 192.168.10.1. Ayan. So now that we already have a default gateway, so meron ako ditong IP ng server. So web server siya, 192.168.30.10. So di ba ibang network na siya, nasa labas na siya nito. Now, I've already pre-configured this with default route. So i-check lang natin kung makakalabas na siya ng network. So I'll just go to my web browser, 192.168.10.30.10. Tingnan natin kung ma-access niya. Request timeout. Let's check sa simulation. Server. Failed. Tingnan natin. So, nag-ARP pa siya. So, we can, pagka ganito may mga failed, we can check yung reason niya dito. So, pwede natin basahin yan. Set default gateway. Tingnan ko kung nag-save yung config ko. Baka kasi hindi siya nag-save. Do show IP route. Meron serial 000. Tama ba? 10.1. Ayun, mali yung IP ko. 168. 68 lang yung nakalagay. So again, let's try. 192.168.30.10. Wait, dapat naka-real time tayo. Ayun, lumabas na yung Cisco Packet Tracer. So, ibig sabihin yan, kaya na niyang lumabas ng network. Diba? Successful na siya. Ayan. So, nakakalabas na siya dahil meron siyang default gateway. So, that's the purpose of our default gateway. Ayan. So, ito na rin yon. So, we can use the show IP interface brief. Ayan. So, let's go to the routing decisions. So, medyo napahaba tayo ng discussion doon. So, for the routing functions, paano daw ba nag-work ang router? So, for example, this is the encapsulation and de-encapsulating ng packets. So, let's say PC1 will send a packet to PC2. Halimbawa, magkausap kayo sa messenger nung kausap mo. Ikaw, nag-send ka ng hi. So, the application layer is yung messenger. The presentation is a text, which is hi. So, yung transport session, so nag-build kayo ng connection para kayo online. The transport, kung anong transport layer ang gagamitin nyo, transport protocol, TCP or UDP. Network layer, kailangan malaman mo yung IP address niya. Layer 2, kailangan malaman mo yung MAC address. So, since it is remote, ang ilalagay mo dito is yung MAC address ng router mo, dun mo siya kasi ipo-forward. And layer 1, i-convert into bits. Now, marireceive siya ni router 1. Sabi natin, router is a layer 3 device. Therefore, ang babasahin lang niya, bubuksan niya yung layer 1, convert niya into frames. Titingnan niya yung destination MAC kung siya ba yun. So, ibig sabihin para sa kanya. Kung hindi, hindi niya kukunin. So, pag nag-match yung MAC address dito at yung MAC address niya, kukunin niya, titingnan niya yung layer 3. So, sabihin niya, saan mo ba gustong pumunta? Titingnan niya yung destination IP address. Sasabihin ni router, titingnan ko sa routing table ko. Nasa routing table ko siya. Kapag ka nasa routing table ko siya, i-forward ko siya, i-re-encapsulate ko siya papunta doon. And it will repeat the process hanggang makarating sa destination. So, si destination, marireceive niya yung bits, convert niya into frames. Makikita niya yung MAC address. Ako ba yun? Yes. Yung destination, that's me. Therefore, the packet or the traffic is for me. And then, i-encapsulate niya hanggang dulo. So, session, presentation niya is text, application, messenger, lalabas yung hi na text. So, that's how we communicate. So, yung encapsulation and de-encapsulation. Yun yung process na nangyayari na sa loob ng router or sa buong network natin. So, this is the more, detailed example. Pero, ganun na rin siya. So, PC1 will send to PC2. So, router 1, titingnan niya yung routing table niya, forward niya kay R2. So, hanggang makarating siya kay PC2. So, ganun din, tulad nung pagkaka-explain ko kanina. So, now, how do routers determine their best path? Diba? Yun yung sabi ng router kanina. Ang isa sa purpose niya is to route traffic or forward traffic using the best path. So, paano ba malalaman ng router ang best path? So, ang pag-choose ng best path always varies on the type of routing protocol na in-implement. For example, may iba't iba kasi tayong klase ng routing protocol. We have static, dynamic, inside dynamic, meron tayong RIP or Routing Information Protocol. We also have EIGRP. So each routing protocol has their own way of choosing the best path. So for example, RIP. Ang RIP or Routing Information Protocol, gumagamit siya ng hop count. Ito. So pag hop count yung tiningnan mo, in choosing the best path, let's say PC1 to PC2, pagdating kay R1, dalawa kasi yung possible way, di ba? Either dito siya dumaan kay R1, R3 or R1, R2, R2, R3. Ngayon, since router 1 is configured with RIP, this network, hop count ang gamit. Diba? So pag tiningnan mo, this one, R1 to R3, that's one hop. R1, R2, one hop. R2, R3, one hop. So 2 hops pag dito siya dumaan. So ang pag hop count, dito ito yung pipiliin niya as best path. Pero pagka ibang routing protocol ang ginamit mo, possible na ito yung gamitin niya kahit ito dalawang hop count. Kasi pag inanalyze mo yung link, R1 to R2 uses tier 1 link. Ibig sabihin mabilis na connection speed meron sila. Same for R2 and R3. Yung R1 to R3 sobrang bagal ng connection niya. Di ba? 56 kilobytes per second. Sobrang bagal niyan. But kung RIP ang ginamit mo, yun pa rin ang pipiliin niya. Kasi nga, isa lang yung hop count. Even though passing to R1, R2, R3 will be much faster. Kasi mas mabilis yung link. Diba? So, choosing the best path always depends on the type of routing protocol na in-implement. So, there are times na merong equal cost na lumalabas. So, routers can do load balancing. So, load balancing, instead of choosing a single best path, gagamitin niya parehas nung best path na yon. So, since they have an equal cost. So, the administrative distance, ano po ba yung administrative distance na binabanggit? A router can have multiple routing protocol installed sa kanya or configured sa kanya. Pwedeng i-configure mo siya with RIP, with OSPF, with EIGRP. Now, kung tatlo yung routing protocol na ginamit mo, yung tatlong yun, hindi pwedeng sabay-sabay gumana. Isa lang yung pipiliin ng router doon as your primary route. Ngayon, paano namimili ang router? So, doon natin ginagamit yung administrative distance, wherein the lower the administrative distance, the higher the trustworthiness ng route. So, ito yung mga administrative distance with regards to their route. So, pag connected, 0 static. So, 1, mataas yung administrative distance niya. So, pag nagsabay, yung static at RIP, which is 120, mas pipiliin niya yung static. Kasi 1 yung administrative distance niya. We have OSPF, 110, ISIS, RIP, 120. So, which route source is more trustworthy? Internal EIGRP, 90, or OSPF, 110. So, therefore, ang pipiliin niya, much more trustworthy is yung internal EIGRP, which has an AD of 90. Ayan. So, router operations. So, the routing table. Ano ba yung routing table? So, sabi natin kanina, it is a map ng router. Diba? Para malaman kung kaya niyang pumunta sa network na yon. But, bago mo malaman yung routing table, kailangan malaman mo muna yung directly connected and remote network routes. So, paano ba natin malalaman yung mga directly connected and remote networks? So, for example, in this topology, with respect to R1, ito yon. So, sa buong topology na to, meron tayong 5 networks dyan. So, ang pag-basis dyan is every interface na connected sa router is considered as a network. So, this is a network 1, 2. This is a network 3. And with this router, so hindi na to kasama, nabilang na siya. This is 3, 4, and 5. So, in this topology, we have 5 networks. With respect to R1, R1 has 3 directly connected networks. Ito po yun. Ang R2, meron din siyang 3 directly connected networks. So since there are 5 networks, si R1 may 3 directly connected networks. Ang remote networks kay R1 is itong dalawa. Ito. Remote siya kasi hindi siya directly connected. For R2, ito yung directly connected. Ito yung remote networks. So si R1, kaya niyang ma-reach yung mga directly connected networks na yan kahit walang routing. So siya mismo siya. But if gusto niyang pumunta sa remote networks, kailangan na niya ng routing protocol. So kailangan mapalista tong mga to sa routing table ni R1. Yon para makarating yung network natin. So ito yung example ng isang remote network entry sa routing table. For example, this is R1's single entry sa routing table niya. Meron siyang D. D stands for EIGRP na route. Ito yung nag-indicate kung paano mo na-learn yung route na to. So you learn the route using EIGRP. This is the network which is 10.1.1.0. So ito pala yon yung network na yan. It has an administrative distance of 90, di ba? 90 ang AD ng EIGRP. Ito yung cost or metric niya via 209.165.200.226. This is the next hop address. So this is R1. Pupunta siya dito. Asan yung next hop niya? Ito. Di ba? Hop. So, ang IP nito is 209.165.200.226. Ito. So, kaya yun yung nakalagay doon. Ito yung timestamp kung gaano na sila huling nag-communicate with the router. And yung exit interface. So, for R1, pupunta dito. Saan ka dadaan para makarating ka sa next hop? Dito. Dito siya e-exit sa interface na to. Serial 000. Kaya yun yung exit interface niya. So that's how we interpret yung remote network entry sa ating routing table. So to show the routing table, you can use the show IP route command. For example, on this router, di ba? Ito yung ginawa ko kanina. So may routing tayo dito. So ito, di ba, humihingi na siya ngayon ng password kasi matagal ko siyang hindi ginamit. So ang ilalagay natin, hindi pa ako nag-enable. So, line console 0 password Cisco. So, the password is Cisco. Diba? Type ko enable. Diba? Enable secret class. Therefore, hihingi ulit siya ng password. The password is class. Diba? Yan. So, IP route. Ito ngayon yung map niya. Ito. So, ito yung mga map. So, meron siyang directly connected and meron siyang S asterisk. So, ito yung default route na kinonfigure ko. So, kanina letter D, di ba? Ito, D, EIGRP. So, yan, may mga list of codes naman na pwede nating tingnan. Ayun. So, ito naman for directly connected network. So, ilalagay lang niya connected and local, yung IP address ng network and the default gateway and yung exit interface. Ito, similar lang. So this is an example. So tulad doon, napakita ko na dito. Static routes. So yung routing ng router can have, sabi ko kanina, pwede siya static routing or dynamic routing. 2 ways to obtain a route. Static routing, which is you manually input your route, and we have the dynamic routing. Yung dynamic routing naman is kung saan na mag-uusap yung mga router. So, i-set mo lang sila as on nung dynamic routing na yon. You just configure the dynamic routing and you let the routers talk to each other using advertisements. Ayun. So, para malaman sa router kung ano yung mga routing protocols na pwede niyang i-implement, you can use the router space question mark command. So, lalabas dyan. So, for example, here, pasok muna tayo ng configure terminal, router, question mark. So, ito yung mga possible routing protocols na pwede kong gamitin. BGP, EIGRP, OSPF, and WIP. Ayan. So let's go to our second topic, which is yung static routing. So we will discuss the implementation and the configuration. Ano bang difference ng static and dynamic? Sabi ko kanina, ang static, manual mo siya i-configure. So bakit po? Yung dynamic, manual mo rin naman siyang i-configure. Diba? Manual mo siya i-configure wherein ikaw mismo yung mag-route. Ikaw yung hahanap ng dadaanan ng router. Ikaw ang maghahanap ng mismong path. Yung static. Yung dynamic, i-on mo lang yung dynamic sa mga routers and then yung routers na yung mag-uusap. Ayan. So, kailan gagamitin yung static? So, this is the comparison ng dynamic and static. When it comes to configuration complexity, ang dynamic, kahit malaking network, same lang yung complexity niya. Yung static routing, habang lumalaki yung network, mas humihirap siyang i-configure. Kasi since manually, for example, meron kang 100 networks, 100 na routes or more ang kailangan mong i-manual input. So sa dynamic, hindi siya ganon. So pagka may nagbago sa topology, ang dynamic automatically, nagre-recompute sila, nag-a-adapt. Ang static routing, kapag may nagbago sa route, kailangan ng administration or administrator intervention. Kailangan ikaw mismo yung magbago. Hindi siya automatic na maghahanap ng panibagong path. So scaling, so mas magandang gamitin ng dynamic kapag mas i-scale mo siya, yung network mo, kahit mas complex. Ang static routing is only suitable for simple topologies. So sa security naman, ang dynamic, less secure siya dahil nagsisend nga siya ng mga updates wherein pwede siyang mas-sniff yung packet, and sa static routing, secure siya dahil wala siyang updates ng mga sinesend. For the resources, mataas gumamit yung dynamic kasi nagkakaroon nga ng computation, so gumagawa siya ng databases minsan. Ang static routing, hindi niya kailangan ng extra resources. And predictability, so the dynamic routing depends on the current topology. Ibig sabihin, halimbawa, dito siya sa daan na to, tumatakbo ngayon. Kapag nagbago yung topology, may chance na hindi na siya dun dumaan. Ang static routing, hanggat kung ano yung dinaanan niya, dun siya lagi dadaan hanggat hindi nagfe-fail yung link na yon. So that's the difference. So ginagamit natin ang static routing when we are routing to stub networks or stub routers. Ano ibig sabihin ng stub network or stub routers? Parang ito na yung mga dulo na network. So wala na siyang kasunod pa. Wala na siyang ibang connections or edge network na siya, kumbaga. So doon natin usually ginagamit yung static kasi konti lang yung network natin dito. Diba? Ito lang. That's point-to-point connection. Diba? So, mas advisable, gumamit ka ng static than dynamic. Next, so we have 4 types of static routing. So, hindi na natin siya i-discuss lahat. Ang ginamit lang natin, ang gagamitin natin mamaya sa demo is yung dynamic default route and yung standard. So we have the standard static route, yung normal na static route natin. Ayan. So from R2 to R1, so since wala siyang route papunta doon, siya na yung manually maglalagay. Ikaw mismo yung magko-code nun. For the default static route naman, so pare-parehas lang sila. Ang gagamitin lang nito is yung quad 0. So ibig sabihin, any network, so ito yung magiging gateway of last resort. Ibig sabihin, pag walang nag-match sa routing table, yun na yung gagamitin niya as next route. Doon na niya ipapadala sa gateway of last resort. We also have the summary static route. So in case we have a lot of IP addresses na magkakalapit naman siya, 21, 22, 20, 23. Pwede mo siyang i-summarize. Ikaw na mismo yung magko-compute into one, and then you use a single summary route. So, instead of using IP route na apat, isa-summarize mo yung apat na IP to get a single summary route. And then ito yung IP route mo. And then we have the floating static route. Yung floating static route is used for backup routes. So, mataas kasi yung administrative distance ng static, kaya pag isinabay mo siya sa, let's say, OSPF, mas pipiliin niya yung static. But you can set it as OSPF yung main, static yung background or backup by changing the administrative distance higher than your primary route. Let's say ang OSPF, ang administrative distance niya is 110. So pagka kinonfigure mo yung static na floating route, kailangan iset mo yung administrative distance niya higher than 110 para siya yung magiging backup and yung OSPF yung magiging primary route. So configuring static and default routes. So we use this command syntax. IP route followed by the network address na gusto mong puntahan, followed by the subnet mask nung network address na yon, followed by either you use your next hop address or your exit interface. So, for example, in this topology, ilang network meron tayo dito? We have 1, 2, 3, 4, and 5 networks. Si R1, meron siyang dalawang directly connected. Therefore, kailangan niya ng 3 IP route para makarating siya dito. Same on R2, 3 directly connected. So, 2 IP routes ang kailangan niya. On R3, same on R1. So, pag nag-show IP route siya, puro connected and local lang. Diba? So, dalawa lang. Wala pa yung mga remote. So, kasi wala pang IP route. So, same on R2 and R3. So, on R1, sabi natin tatlo yung remote niya. 16.1.0, 192.168.1.0, and 192.168.2.0. Therefore, these network addresses, yun yung ilalagay niya sa IP route. Using the command IP route, 172.16.1.0, this is the network address, followed by your subnet mask, followed by, ang ginamit niya is the next hop address. Kasi ito si R1, di ba? Ito yung next hop niya. Anong address nito? 172.16.2.2. Ayan. So, ang tawag dito is next hop static route. You can also do the, after niyang gawin yon, so lalabas na yan, may mga S na siya dyan, S. Ibig sabihin, meron na siyang static routing. Ngayon, makakarating na yung PC1 sa PC3 and PC2. Ngayon, ang problem is yung pag nag-send ka ng message, it requires a reply. So, yung PC2, hindi siya makaka-reply kay PC1. So, failed pa rin yon. So, kailangan yung R2 and R3 should also be configured with static routing. So, for configuring a directly connected naman static route, kanina next hop address. Pag directly connected, you use the exit interface. Diba? R1 to R2. Saan siya mag-e-exit? Dito, sa serial 000. So, yun yung ilalagay mo sa dulo. Network, subnet mask, exit interface. If you want to do a fully connected static route, you input your exit interface together with your next hop. Parehas mo silang gagamitin. IP route, the network address, subnet mask, exit interface, G01, and then the next hop, 172.16.2.2. So some some networks require, ang nire-require nila yung fully specified static route. Ayan. So, pagka nag-show IP route ka, may lalabas na siya na route, which is yung static or S. So, verifying static route, you can use the command show IP route static para makita mo kung may route ka na ba papunta doon. So, syempre, that's just a part of routing. Kailangan mo rin siyang gawin for R2 and R3. Ayan. Ayan. So for the default static route naman, so kung kanina, ang ginagawa natin is yung network address, subnet mask. Ngayon, ang ilalagay mo is 0.0.0. Ang tawag dito is quad 0 na routing. Ibig sabihin, any network magmamatch sa kanya, di ba? Matches any network address. So kahit anong network na ma-receive ko na wala sa routing table ko, dito niya ipapadala sa kung ano mang iseset mo na default route. For example, R1, nag-IP route siya, default route, and then he uses the next hop address. So any packets na isesend ni PC1 na wala sa routing table ni R1, dito niya ipapadala kay default route, yung 172.16.2.2. Dito niya ipo-forward. Ayan. So yun kasi yung tawag din sa default static route is yung gateway of last resort. Ayan, gateway of last resort is 172.16.2.2. Anong ibig sabihin nun? Kapag ka nag-send siya, naka-receive yung router ng packets na wala yung destination sa IP routing table niya, yun yung last resort. Ibig sabihin, wala na akong choice. Dito na kita ipadadala. Diba? So yun yung purpose ng default static route. Usually, ginagamit siya sa connection natin papunta sa internet since it is point-to-point connections. Yan. Sa mga point-to-point connections siya usually ginagamit. And sa mga stub networks. So, punta na tayo sa third topic natin. So, the dynamic routing. So, we will discuss the protocols, specifically the RIP version 2 and the routing table. Ayan. So, ang dynamic routing protocol, it could be divided into IGP or Interior Gateway or EGP. So, medyo advanced na yung mga discussion na ganyan. So, ang pinili ko lang dito is we will discuss the RIP version 2, which is under siya ng distance vector. So, ang ginagamit sa mga large networks, yung OSPF, ISIS, and EIGRP. Ayan. So, yung BGP natin, so yan yung ginagamit ng mga service providers or ISPs. Ang purpose po ng Dynamic Routing Protocol is to discover remote networks. Ganun din naman, maintain up-to-date routing. So, sila na yung mag-uusap. And choose the best path to destination networks. Find a new best path pagka hindi na available yon. Main components ng dynamic is yung data structures natin, routing protocol messages, and the algorithm. So each routing protocol sa dynamic, meron silang kanya-kanyang algorithms na sinusunod. So, ang idea ng dynamic routing is i-on mo yung routing dito, on, on, on. And then yung tatlong router, mag-uusap na sila. Magsisend na sila ng updates, advertisements, and then hanggang makabuo sila ng routing table. So, hindi na siya kailangan lagi ng administrator na laging magmo-monitor or mag-a-update. Kasi yung router, automatic, mag-a-updates na sila. So, kaya siya ay less secured kasi nga nagsisend siya ng broadcast packets na pwedeng ma-sniff kapag mali yung pagkakakonfigure natin sa routing protocol. So, dynamic versus static, I guess I've already discussed this earlier. And so ito, maliit na network lang, pwede ang static. So ito, sa network na to, try mo gawin yung static. Di ba sobrang hirap niya i-static kasi hahanapan mo siya, ilan bang network yan. So sa dynamic, per router, yung configuration, tapos i-on mo lang siya nga, and then sila na yung bahalang mag-usap. And for our first webinar code, so ito po siya, EDC 0806. Paki-take note na lang po para sa post-evaluation. Okay na po ba? So, let's continue. So, doon na tayo sa specifically na dynamic routing, which is yung RIP version 2 or the Routing Information Protocol version 2. So, yung RIP version 2 natin, so ang objectives nito, implement RIP, configure RIP. Yung RIP version 2, as I've mentioned earlier, ang metric na ginagamit niya is hop count. So, dynamic routing siya, pero hindi rin siya advisable gamitin sa sobrang laking networks. Kasi, ang RIP, medyo matagal yung converge time niya. Yung update kasi niya, nagsisend every 15 seconds. So, pagka may nag-down na connection, 15 seconds pa bago malaman ng router na may nag-down. So, kumbaga mabagal yung update niya. So, ginagamit yung RIP sa medyo malaki na routing protocol pero hindi sobrang kalakihan. Yan. So, to configure RIP, ayan, ang algorithm na ginagamit ng RIP is yung Bellman-Ford algorithm. So, which uses yung hop count, ayan, to choose the best path. So, to configure RIP sa ating router, papasok lang tayo ng config T and then router RIP. And then pagka nag-question mark ka sa loob ng router RIP, ito yung mga commands na pwede natin gamitin. So, yung mga naka-read yan, yung mga usually command na ginagamit. Yung version, passive interface, network, default information, and the auto summary. So, yan yung mga usual commands. So, since baka magkulang sa time, ang ginawa ko na lang is sa dulo, lahat ng mga diniscuss natin, isang packet tracer activity na lang, and then, i-combine ko na lang doon. So, doon ko i-discuss ng deeper yung RIP configuration. So, yung R1, ang pag-advertise ng networks niya, kasi yun yung way kung paano tayo mag-route sa dynamic. Sa static kasi, di ba, nasa R1 ka. Pag static, kailangan alam mo yung network na pupuntahan mo. Kasi, ikaw mismo yung automatic maglalagay sa R1 mo, routing table. Di po ba? Yun yung ginawa natin kanina. Ngayon, sa RIP, ang kailangan mo lang gawin is i-advertise yung network mo mismo, yung directly connected sa'yo. Let's say this is R1. Meron siyang 2 directly connected networks, 192.168.1.0 and 2.0. Therefore, ito lang dalawang network na to ang i-advertise mo. So, halimbawa, may internet connection ka dito sa taas, ayaw mo i-advertise, ayaw mo silang magka-internet, edi hindi mo sila kailangang isama. Yung directly connected lang ang isasama mo. Ayan. So, you use the command network and then the network address 192.168.1.0. Again, network 192.168.2.0. So, by that, in-on mo na yung R1. Pag ginawa mo yun kay R2, si R2, meron siyang 3 directly connected. So, ito yung i-advertise niya. Network 3.0, 2.0, and 4.0. So, ngayon, mag-uusap ngayon yung R1 and R2. Sasabihin ni R1 kay R2, hey R2, this is my networks. Sasabihin ni R2, okay. Si 2.0, kilala ko na yan. Directly connected sa akin yan eh. Si 1.0, hindi ko to kilala. Sige, ililista ko to. Saan ko ba to na-receive? Sa interface na to, so yun yung ilalagay ko na exit interface, and sa IP address na to. Ito yung ilalagay ko na next hop. So by that, mag-uusap-usap yung mga router na yan. Sige, ito hindi ko pa kilala. O sige, ilalagay ko yan sa routing table ko. Hanggang mapuno yung routing table niya na mamap na niya yung buong network. So pagka may nag-down, after 15 seconds, magsisend ulit sila ng updates. Tapos, namatay na pala yung network na to. Alisin na ngayon ni R2 yon. So parang ganun sila nagwo-work yung updates nila. And to verify yung RIP, we can use the show IP protocols. So para lumabas kung ano yung protocol na gamit mo. So you're using RIP and other informations, sending updates every 30 seconds. Yan. Enabling the version 2. Ang version 2, difference niya sa version 1 is, ang version 1 kasi, kaya lang niyang mag-route ng class full addresses. Hindi niya sinusupport ng VLSM or classless. Ang version 2, kahit classless networks, kaya na niya i-route. So kaya laging ginagamit yung version 2. So for sa pagka nag-configure tayo ng RIP, lagi nating disable yung no auto summary kung hindi mo siya gagamitin. Kasi there are chances na baka i-summarize niya yung routes and then may pumasok na mga network na hindi naman siya dapat kasama dun sa mga mara-route ng RIP. Kaya for safety purposes, we use the no auto summary command. Ayan. So passive interfaces, sabi ko kanina, di ba yung routers, nagsisend sila ng advertisements. Yung advertisement na yon, router lang ang nakakaintindi. So, yung advertisement na yon is broadcast. Diba? Pag broadcast message, ibig sabihin, ipa-flood niya yon sa lahat ng interfaces niya maliban sa pinanggalingan. So, halimbawa si R1, nag-send siya ng broadcast. Pupunta siya dito, pupunta siya doon sa G00 and serial 000. Yung G00, wala namang router dito, di ba? LAN na to eh. So, aanhin mo yung RIP dito. Hindi mo siya kailangang bigyan ng RIP. Delikado pa, pag may nakakonect ditong attacker, makikita niya yon, magkakaroon na siya ng idea, okay, RIP pala gamit nyo. Diba? So, makakakuha siya ng information. Kaya, ang ginagawa is, if a link ng router na yon is connected to the LAN, you configure that as passive interface. So that the router updates won't go or hindi siya magpo-forward ng broadcast updates sa link na yon pag sinet mo siya as passive. So ito, wag mo ipa-passive kasi hindi niya makakausap si R2, 'di ba? Ang hindi mo ipa-passive yung mga connected kay routers or connection mo papunta sa ibang routers. Propagating a default route, so sabi ko kanina, pag may internet ka dito, tas nag-RIP ka, pwede mong hindi siya i-propagate. Yan ba, nag-default route ka dito kasi it's point-to-point, di ba? Ngayon, kung gusto mo silang bigyan ng internet and you want to propagate this, hindi mo siya sa network ilalagay. Gagamitin mo lang yung default information originate command. Sa loob ng router RIP, automatic, kung meron kang default route, which is this one, automatic ipopropagate niya sa buong RIP networks mo. That's how the RIP works. So, let's discuss now yung chapter 4 or topic 4 natin, which is the switch networks. So, medyo pahinga muna tayo sa router. Sa switch muna tayo naman. So, we will discuss the LAN designs and the switch environments. And this will be the objectives of this chapter. Ayan. So, ang LAN design natin, meron tayong tinatawag na access layer, distribution layer, and core layers. So, usually, the access layers, ito yung connection papunta sa mga end devices. Yung distribution layer, it is an interface between the access layer and the core layers. And yung core layer naman is yung the network backbone that provides fault isolation and high-speed connection sa network natin. So itong sa figure na to, it is a collapsed distribution and core. So magkasama na sila. So smaller networks that do not need a separation distribution and core layer often use a two-tier campus or collapsed core network design like this one. Kapag hindi naman masyadong malaki or maliit lang naman yung networks natin. So yung switches natin, meron tayong iba't ibang form factors. So meron tayong fixed configuration, we have the stackable configuration and modular configuration. Yung fixed configuration, halimbawa may switch tayo, may dalawa kang switch na 24 ports, hindi mo siya pwedeng i-combine. So, dalawang switch yon na magkahiwalay mismo. Ang stackable, pagka may dalawa kang stackable na 24-port switch, yung port numbering niya magko-combine or port density. So, halimbawa, may dalawa kang 24. So, yung isa, 0 to 24, yung isang mong switch magiging 025 to 048. So, yun yung stackable configuration. And we also have the modular configuration. So, ito yung sa mga data centers na ginagamit na para siya yung mga network interface card na malalaki. Parang ibinabala mo lang siya sa ref. So, yun yung modular. So, usually sa data centers yan ginagamit. So, these are the considerations when selecting switches. So, first, yung cost. So, medyo mahal kasi siya kapag kaya mga Cisco devices. But, may mga advantages siya kapag lahat ng devices mo is Cisco since you can use the Cisco proprietary protocols na offered by Cisco. So, you also need to consider the port density. Halimbawa, magse-setup ka ng network na 30 units. Diba? So, alangang bumili ka ng isang switch na 24 ports. Paano may connect yung ibang devices? Diba? So, you need to always consider your port density. Pag sinabi nating port density, yun yung number ng ports na available sa switch na yon. The power, so nag-offer ba siya ng PPPoE or power over Ethernet? So, reliable ba yung switch na yon? Port speed, so pwede ba siya 100 Mbps or 1 Gbps? Fast Ethernet ba siya or Gigabit Ethernet? So, and frame buffers and kung scalable siya or scalability. So, for a switch environment, so sabi natin kanina, ang router kapag nagde-decide siya, gumagamit siya ng routing table, di ba? Ang switch, gumagamit siya ng tinatawag nating MAC address table na binubuo niya habang nakaka-receive siya or nagsisend siya ng frames sa isang network. Ayan. So, nagbe-base siya sa ingress and egress port. Ingress port is kung saan dumaan yung frame. Yan. So, halimbawa, sa port 1, nakaka-receive siya ng isang frame from EE. Ito, nakalagay. Pag port 1, papunta siya kay EE. So, ito, destination address niya is EA. So, si EE nag-send sa port 1, destination EA. Titingnan niya EA, port 4. Therefore, dito niya sa port 4 palalabasin yung frame. Doon niya i-forward. So, ito yung example ng MAC address table ng isang switch. So, I have here a video presentation discussing yung MAC address table natin. So, let me just play the video from tab, share. Ayan.
In this video, PCA is going to send an Ethernet frame to PCB, and PCB is going to send an Ethernet frame to PCA. We're going to examine how switches S1 and S2 build their MAC address tables, and also how they forward frames based on the information in those MAC address tables. PCA has an Ethernet frame to send to PCB. The source MAC address of the frame is 000A and the destination MAC address is 000B. The Ethernet frame is sent to switch S1. S1 receives the Ethernet frame, examines the source MAC address, and notices that this MAC address is not in its MAC address table, so it adds the MAC address and the incoming port number. Next, switch S1 examines the destination MAC address and notices that this MAC address is not in its table, so it floods it out all ports. PCB receives the Ethernet frame, examines the destination MAC address against its own MAC address, and notices that that is a match and receives the rest of the frame. The Ethernet frame continues to be forwarded to switch S2. Switch S2 examines the source MAC address of the frame and notices it is not in its MAC address table, so it adds the MAC address and the incoming port to its MAC address table. Next, switch S2 examines the destination MAC address, notices that is not in its MAC address table, so it floods it out all ports. PCC receives the Ethernet frame and its MAC address does not match the destination MAC address of the Ethernet frame, so it does not accept the rest of the frame. The router receives the Ethernet frame, examines the destination MAC address against its own MAC address, and notices it is not a match, so it does not receive the rest of the frame. Now let's have PCB sending a frame back to PCA. The source MAC address of the frame is 000B, and the destination MAC address is 000A. PCB sends it to switch S1. S1 notices that the source MAC address is not in its MAC address table, so it adds the MAC address and the incoming port number. Next, switch S1 examines the destination MAC address and notices that MAC address is in its MAC address table. So it sends it out just port 1. PCA receives the Ethernet frame, examines the destination MAC address against its own MAC address, and notices it is a match, so it receives the rest of the frame.
Ayan. Let's get back. So, ayun po. So, based on that video, let me just play it again. Dinidiscuss lang siya na kung paano nag-build ng MAC address table yung switches natin. So, every time na may marireceive siya na frame on a port, titingnan niya yung MAC address table niya. Kapag wala doon, i-examine niya yung MAC address and port na pinasukan or ingress port and i-update niya yung MAC address table niya. So, ganun siya nagwo-work. So, paulit-ulit lang siya hanggang mapuno yung MAC address table ng isang switch. Ayan. So, yun yung ibig sabihin ng video natin doon. So, that's how a switch builds his MAC address table. So a switch, so since 'di ba ang gamit ng switch is frame yung binabasa niya. So meron tayong tinatawag na frame forwarding. So we have two ways on how to forward traffic or frame ang isang switch. It's either you use a store and forward, which is mas reliable siya because it receives the whole frame first, check yung CRC or cyclic redundancy check kung nag-match bago niya ipadala sa destination. Medyo mabagal siya pero siya ay reliable. Ang counterpart niya is yung cut-through switch forwarding wherein nire-receive lang niya yung minimum 64 bytes of data. Gusto lang niyang malaman yung destination MAC address. Once na alam na niya yung destination MAC address, kahit hindi pa tapos i-forward yung buong frame, ipapadala na niya. So, mas mabilis siya. Pero walang error checking. Kaya hindi reliable masyado, pero mabilis yung pag-forward ng traffic. So, for example, here, itong gray na to, ito yung packet natin, which is data. Ito, data. Pag nilagyan mo siya ng transport header, ang tawag na dyan is segment. Pag nilagyan mo siya network header, ang tawag na dyan is packets. Ngayon, pag nilagyan mo siya ng frame header and frame trailer, frame na ang tawag dyan. So, inside this frame header, andyan yung preamble, the destination MAC address and source MAC address, and yung type nung frame. Sa frame trailer, merong nakalagay na FCS or frame check sequence. wherein ito yung cyclic redundancy check na may value siya bago umalis ng source. Pagdating sa switch, titingnan niya, i-compare niya kung parehas. Kasi kapag hindi siya nag-match, hindi niya i-receive yung frame kasi ibig sabihin nun, either yung frame na yon ay nagkaroon ng collision or may umedit dun sa frame na yon. So possible na ganun yung nangyari. Kaya for security purposes, pagka hindi nag-match yung frame check sequence niya, hindi niya nire-receive yung or hindi niya pina-forward yung frame. So ito yung store and forward. Kukunin niya yung buong to, check the frame check sequence, if okay, isi-send na niya. So, yung cut-through method naman, ang titingnan lang niya is yung first 12 bytes, 14 bytes of data kasi sa first 14 bytes, makikita na niya yung destination MAC address. Kung baka parang atat na atat itong cut-through. Sige na, bigay mo na sa akin yung destination para ma-forward ko na kahit di mo pa tapos i-forward lahat. Mabilis siya, pero pwede siyang magkaroon ng problem kasi hindi mo chinek yung reliability ng frame na sinesend sa'yo. So may instances na cut-through yung gagamitin, pwede rin naman na store and forward. Depende kung ano yung kailangan. So kung gusto mo na mas mabilis, kahit di reliable, you use the cut-through. Kung yung data na tumatakbo sa'yo is important data, pwede na yung store and forward. Ayan. So rapid frame forwarding and it is fragment free. Collision domains. Ito. So, sa pag-discuss ng collision domains, gagamit ako ng packet tracer. Saan na yan? Ito. So, in a collision domain, ang collision domain kasi, nagva-vary siya kung anong devices ang gamit mo. So, for example, ang hub only has a single collision domain. Ang hub kasi, ang tawag sa kanya is a dumb device. Ibig sabihin, hindi kasi siya nag-iisip. Di ba yung switch natin, binanggit natin kanina, na may MAC address table siya. Doon siya nagbe-base kung kanino niya i-forward yung traffic. Ang hub, basta naka-receive siya ng frame, i-forward niya. So mataas yung level of collision sa hub. So pag naka-receive siya ng frame dito, i-broadcast niya yung frame. So papadala niya sa lahat. So for example, nag-ping si PC2 to PC4. Pag tinignan natin siya sa simulation, sinend kay hub. Si hub, hindi siya nag-iisip. Kung si switch yan, titingnan niya yung destination MAC address. Di ba? Si hub, wala siyang ganon. Basta naka-receive siya, forward niya, broadcast. Ito, na-receive niya kahit hindi naman sa kanya. Di ba? So, pwede niyang kainin yung bandwidth nito. Madaming nasasayang na bandwidth. So, si hub, yon. So, na-receive ni PC, pag magre-reply siya, so, syempre, ma-receive ulit ni hub, i-broadcast niya ulit. Diba? So, hub, ang napapalaki niya, sobrang laki ng broadcast domain niya or yung collision domain niya, lalo na pagka marami yung connected sa kanya. Mataas yung chance na magkaroon ng collision. For example, ayan. Nag-send ako si PC2 kay PC4 at the same time si PC3 nag-send kay PC2. Pag sinimulate natin, ito, ready na silang dalawa, sabay magpapadala. Pagdating kay hub, nagkaroon ng collision. So, i-hide ko lang yung port labels. Di ba? Nagkaroon ng collision, nasunog yung frame. So, status niya is collided because it is a hub. It has a single collision domain. So, kahit gaano kadami yan, ports na connected sa kanya, mas lumalaki yung collision domain niya. So, mas tumataas yung chance na magkaroon ng collision. So, after that, wala na. Hindi mo na na-receive ng ayos. So, failed na yung status nung connection mo. But, if we connect it, i-reconnect ko lang sila using switch. Ayan. Fast forward. Ayan. So let's try sa switch. 'Di ba? Ang switch, kaya niyan tingnan. Saan mo destination? Dito. Doon niya ipapadala lang. 'Di ba? Nakakapag-isip kasi siya. Ayan. And it works on full duplex. Pwede siya send and receive. Sasabay. For example, gawin ko yung ginawa ko kanina. Ayan. Simulation. Di ba sabay ulit silang magsisend? Pagdating sa switch, hindi siya magko-collide. Kasi each port ng switch has their own collision domain. Ibig sabihin dito, sa topology na to, I have 3 collision domains. Iba yung collision domain nito, iba to. Therefore, hindi sila magko-collide. Para siyang tatlong sasakyan na may tigi-tigisang lane. Hindi sila pwedeng magbanggaan. Diba? That's the advantage ng switch. So kahit magsabay sila dyan, hindi sila magko-collide. And magsasuccessful sila. Ang hub, para kang may tatlong sasakyan, tapos may isa lang yung one way yung daan, tapos magpipilitan kayong magsiksikan sa paggamit ng kalsada. Kaya nagkakaroon ng collision. So, yun yung collision domain natin. Yung broadcast domain naman, so ito yung kung gaano kalayo yung broadcast na marireach ng network natin or ng switch networks natin. So, ang isang switch, meron siyang single broadcast domain tulad nito. Pag nag-send siya ng broadcast sa lahat, ifa-forward niya. Pag yung switch, kinonect mo sa isa pang switch, ilan yung broadcast domain? Isa pa rin. Kasi yung broadcast dito, makakarating doon. So, paglaki ng broadcast domain, pagtaas ng chance na mag-congest yung network. Kasi yung broadcast kasi, paikot-ikot kasi yan sa network hanggat hindi na uubos yung ports na pagpapadalhan niya. So, ang ginagawa to alleviate that is you implement a VLAN or you use a router. Kasi yung router, it divides yung broadcast domain. Halimbawa, lalagyan mo siya dito ng router sa gitna, magkahiwalay na broadcast domain na siya. Hindi na siya, yung router, pag naka-receive siya ng broadcast dito, hindi na niya basta ipo-forward doon. So, nahahati yung broadcast domain, mas gumaganda yung network. Or, pwede mo rin gamitin is yung VLAN or the virtual LANs. Ayan. So, for next topic, so switch configuration. So, ito naman yung basic switch configuration natin. So, similar lang siya dun sa basic configuration ng router. Lalagyan mo rin siya ng mga line console, line VTY, enable secret, enable class, service password encryption, and so on. So, yung front panel ng switch, may mga ibig sabihin yung mga LED states na yan. So, yung LED na yan, kapag ka-off, so ibig sabihin, either naka-shutdown yung link or wala kang nilagay na link or RJ45 na cable, Ethernet cable. Pagka umilaw siya ng green, so may link na present. Pagka nag-blink siya ng green, ibig sabihin nagta-transfer siya ng data or may data activity. Alternating green and amber, ibig sabihin may link fault. And amber port, not sending data, common for first 30 seconds of connectivity or activation. So, ang switch daw, pagka nag-connect ka ng isang device, sa una, amber talaga siya kasi nag-process pa. Nag-activation pa. So, matagal yan. So, ang packet tracer lang, may fast forward time siya kaya mas napapabilis mo yung oras. Pero sa una, amber talaga siya. And kapag ka blinking amber is sadyang nakablock yung port na yon to prevent a loop sa ating network. Ayan. So for basic switch management, ganun din tulad ng nabanggit ko sa router, we use a console cable na nakikita sa likod ng switch. Ayan. So these are the basic switch configurations. Bukod dun sa nabanggit ko kanina, di ba sabi natin, ang switch kasi is a layer 2 device. Hindi siya dapat nalalagyan ng IP address. Tingnan natin yung mga ports niya. ConFT, enable, ConFT. Papasok ako sa isang port, INTFA01. Hindi ko siya kayang lagyan ng IP address. Ayan o. Walang IP address command kasi siya ay switch port, layer to device. So, paano mo siya ma-remote access or ma-SSH or telnet? So, you create a VLAN, ito, VLAN 99 for management VLAN. Doon mo ilalagay yung IP address mo. Ayan. Para remote access mo siya. And it is important to put a default gateway sa ating switches kung may default gateway siya. For example, asan na yung isa kong, ito pala. Ito switch, may default gateway siya dito. It is important that you also put your default gateway sa switch using the IP default gateway command. Ito, IP default gateway followed by your default gateway. And when we are configuring, so to save your configuration, you use the copy command, your running config, yung config mo ngayon to your startup config. Para sa sunod na mag-start up yung device, ang nasa startup na is yung running config mo. Parang sinesave mo siya. So that's how you save your configuration. So duplex communications. So switch ports, nabanggit ko kanina, it can work as full duplex or half duplex. Pag full duplex, it can send and receive simultaneously. For half duplex, so para siyang one-way, unidirectional. It's either you send or you receive. Ayan. So to change the duplex of your switch ports, papasok ka lang sa interface and you use the duplex command. Duplex, it's either full or half or auto, meaning auto-negotiate. Pagka naka-auto-negotiate ang switch port, ang duplex mo, halimbawa, yung isa ay auto, yung isa ay full, automatic yung auto magiging full. Halimbawa is auto tapos half, automatic magiging half yung auto. So, you can also change the speed. So, pwede mo siyang i-work on 100 Mbps. Halimbawa, isang device lang yung connected sa switch na yon. Tapos, ang lakas niyang kumain ng data or ng bandwidth, pwede mong i-limit yung speed na tatakbo sa link na yon using the speed command. Kung gusto mo 1 MB, mabilis pa eh. Alam mo, gusto mo KB, pwede mong babaan yung speed na yon. So we also have auto MDICs. So if we are familiar with straight through and crossover cables, di ba? Ang crossover cable, ang straight through cable, kailan natin ginagamit? When we are connecting two different devices, straight through cable. Pagka similar device like this one, switch to switch, we usually use the crossover cable. So we have an option to configure the auto MDICs para kahit mali yung cable na gamit mo, kahit crossover cable, kahit straight through cable, gagana pa rin siya. So yun yung purpose ng ating auto MDIX. So sa loob pa rin siya ng interface, dun pa rin natin siya i-configure using the MDIX auto command. So purpose niya, pag kahit hindi na siya nagre-require ng straight through or crossover. So kahit anong cable ang gamitin mo, gagana na siya. So for the switch security, so main security kahit hindi sa switch, kahit sa router, is to use an SSH for remote access. Counterpart ng SSH is telnet. So you can, if you use a Wireshark to capture a telnet, Wireshark is an application that can sniff or can filter traffic sa network mo, TCP, UDP streams. So if you pick a telnet, kaya mong makita yung laman niya. Kasi yung telnet, unsecure plain text and passwords yung data transmission niya, hindi siya encrypted. Unlike yung SSH na encrypted yung data. So SSH or secure shell is an alternative protocol for telnet. So it uses a secured version ng telnet that has an encryption para secured yung data transfer natin, especially yung mga login details natin and credentials sa router. So para malaman kung ang device is capable of using SSH, so you just use the show version command ng OS mo and it should have a K9. Sorry. So dapat may K9 siya sa dulo ng iOS version mo para malaman mo na it includes cryptographic capabilities na kailangan ng SSH. So to configure SSH, ayan, first, you need to verify SSH support. Yun nga, yung show version. Next is you configure the IP domain name. This one, lagi siya nakakalimutan. Yung cisco.com, this is for example lang. Pero kung anong domain name yung gagamitin mo, pwede siya, kahit ano. And then you generate an RSA key. So crypto key, generate an RSA. And then you pick the 1024 modulus since you're gonna use the version 2. Create or configure a user authentication. Ito, username, admin, secret, CCNA. I've already explained what a secret is. Configure the VTY lines kasi ang telnet or SSH is a remote access. So, dito siya papasok sa VTY. Line VTY 015 dahil siya ay switch. Transport input SSH kasi ang default niya is telnet. So, babaguhin mo nga siya, gagawin mo siya SSH. So, you use the command transport input SSH. And then, login local, exit, and then you enable the version 2. IPSSH version 2. So, the login local command forces the use of a local database for username and password. So, ito yon. Ito lang yung magiging username and password mo. So that's how you use an SSH or configure an SSH. This is yung example ng PATI na nabanggit ko kanina. So if you're gonna use serial or yung console, ito yung i-check mo, serial. Tas okay na. Pagka SSH, click SSH here, yung IP ng switch or router, and then papasok ka na dito. Log in as admin, and then yung CCNA, which is your password. After that, makakapasok ka na dun sa switch. So, mas secured siya compared dun sa telnet natin. So, another security na pwede nating i-apply sa router sa switch is shutting down the ports. So, using the no shutdown command. Ayan. Shutdown command. Kasi by default, sabi ko kanina, balik tayo dito sa mga example natin, di ba? Pagka meron akong, halimbawa, attacker ako, kumonek ako sa isang switch na exposed sa isang company, maghihintay lang ako, connected na ako doon, di ba? But, if I turn off, if I shut down all the unused ports, paano ba yun ginagawa? So, interface, range, FA010 to 24. Ayan. Shutdown ko siya. Shutdown. Ayan. So, nag-shutdown na siya. So, kapag may isang attacker, ko-connect siya sa port 10 to 24 yung sinutdown ko eh. Sa port 12. Diba? Red siya. So kahit anong intay niya, hindi siya automatically ko-connect because the port of the switch is shut down. So by default kasi hindi siya naka-shutdown, 'di ba? Pag connect mo, connected agad. So security breach 'yon. Kapag lalo na pag yung mga switches natin is naka-exposed. So kaya by default, you shut down all unused ports. Ayan. So nandito na tayo sa last topic natin, which is yung VLANs. We will discuss the segmentation and implementations. Inter-VLAN routing using routers. So para saan po ba ang VLANs? Sabi ko kanina, ang switch di ba, has a single broadcast domain. So pag kinonect mo siya sa switch, single broadcast domain lang din siya. So VLANs or virtual LANs, para siyang familiar tayo sa pag-partition ng hard drive, di ba? So pagka pinartition mo yung hard drive, isang hard drive lang yon. Pero you can partition it into several partitions. Parang ganun din siya, yung VLANs. You all exist on a single LAN, pero virtually, pwede mo siyang i-partition. Halimbawa, gusto mong, this is a single LAN. Gusto mong magkita-kita lang yung mga IT department, HR department, sales department in your LAN. So, hindi mo pwedeng, ayaw mong magkita yung IT at HR na data or files sa networks. So, you create a virtual LAN and you incorporate those devices or those ports sa loob ng virtual LAN na yon. So, it limits the broadcast domains ng LANs natin. So, parang instead of buying another switch para maghiwalay yung dalawang yon, you just partition your own switch into several VLANs. So, yun yung purpose niya. Ang benefits ng VLANs is it improved security. Ayun nga, kasi napaghihiwalay mo yung mga devices, napapartition mo sila, it reduced cost kasi instead of buying another switch for another network, so you can just create a VLAN for that, and it has better performance kasi nalilimit mo yung broadcast domain. So, in case mag-send ng broadcast yung isa, di ba? Example, wala tong VLAN. Ito nag-send ng broadcast, lahat sila makaka-receive. Eh kung may VLAN to, pag nag-send to ng broadcast, hindi niya ma-receive kasi they are not on a single LAN. Diba? Wala sila sa isang LAN. And pag tiningnan mo yung network niya, so siya classless /24, 172, so tatlo, nasa ibang network sila. So hindi talaga sila magkikita. So it's smaller, the broadcast domains, mas efficient siya, and mas madaling i-manage. And simpler project and application management. So there are different types of VLANs. So we have the default VLAN. So by default, sa switch natin, meron na tayong default VLAN which is the VLAN 1. All the ports of our switch by default is part of VLAN 1. We also have the data VLAN. So data VLANs are commonly created for a specific group of users or device na nag-generate ng traffic. So we also have the native VLAN. So native VLAN carries all untagged traffic. So nanggagaling sa mga VLAN ports. And we also have the management VLAN. So ito yung VLAN 99 usually, or yung native VLAN, ginagawa ring VLAN 99. Yung management VLAN, ito yung VLAN na nilalagyan natin ng IP address or SVI, Switch Virtual Interface, yung pinakita ko kanina. So, isa sa VLANs is yung VLAN trunks. So, yung VLAN trunks, ano po ba yung trunk? So, halimbawa sa puno. Di ba yung puno meron siyang trunk, may branches siya. Yung VLANs para mga branches. Diba? So, if you want to go from one branch to another, kailangan mong dumaan ng trunk or trunk link or VLAN trunks. So, yung VLAN trunks na yan is a point-to-point link that carries more than one VLAN. Ito kasi, for example, this is VLAN 10. Pang VLAN 10 lang to. Ito, pag trunk link to, pwede mong iset na pwede dumaan dito VLAN 10, VLAN 20, VLAN 30, and so on. Pwede rin na VLAN 99, which is yung mga untagged VLAN. So, yun yung purpose ng trunk link. So, the links between switch 1 and switch 2 and switch 1 and switch 3 are configured as trunks para makatawid sila from this side to this side. Kasi di ba VLAN 10 to 20, hindi naman sila pwedeng magkita. Sino lang yung pwedeng i-connect ng faculty na VLAN 10? Yung faculty rin na VLAN 10. So, paano siya tatawid papunta doon? Kailangan niya ng trunk na dadaanan. Actually, kahit nga wala yung switch 1, kahit mag point-to-point sila dito and use a trunk link, pwede na yon as a trunk link para makatawid. So, paano natin nalalaman kung saang VLAN kasama yung isang frame? So, nagkakaroon tayo ng tinatawag na VLAN tagging. So, sa loob ng frame, ito yung frame. So, destination and source MAC address. Sa loob nun, nilalagyan ng singit na tag. Sa loob ng tag, inilalagay yung VLAN ID, which is your ID ng VLAN. Halimbawa, VLAN 10. Ilalagay niya dito 10. Ko-convert niya into bits. Kaya nagiging 12 bits siya. So, ang tawag dito is the IEEE 802.1Q or the VLAN tagging. So, frame tagging na protocol. So, encapsulation .1Q ang ginagamit. So, for the VLAN implementation, so we have two categories ng VLAN. So, we have the normal range and the extended range. Kung yung VLAN number natin is from 1 to 1005, it is a normal range VLAN. Ang configuration niya nag-store sa VLAN ... which is inside the flash memory. Ang extended range VLANs naman po ay from 1006 to 4096. And yung extended range VLANs are stored in our NVRAM or the non-volatile RAM. And so, on a Cisco Catalyst 2960 and 3560 series, it can support 4,000 VLANs. So, to show yung VLANs natin, we can use the show VLAN brief commands. Yan. So, how do we create a VLAN? So, madali lang. Pasok ka lang ng configure terminal. Let's say, gagawa ka ng VLAN 20 with the name student. So, you use the command VLAN, followed by the VLAN ID 20, and then name, followed by your name ng VLAN, student, and then end. After that, pagka nag-show VLAN ka na, papasok na yon sa VLAN natin. So, para mas madali nating makita, dito ko na lang siya gagawin sa switch. Enable configure terminal to show VLAN. So, by default, all ports, ito yung mga ports natin, are part of VLAN 1. Let's say, pakita ko lang yung port labels. Halimbawa, itong device na to, sa FA03, ilagay natin siya sa isang VLAN. Fill. Ayan. VLAN 20, the student. FA03. So, kailangan, gumawa muna ako ng VLAN. VLAN 20. Name, student. Pag nag-do show VLAN ako ulit, lalabas na siya dyan. VLAN 20, student. Kaso, wala siyang port. Ano ba yung port na gamit ng VLAN na yon? FA03, di ba? Therefore, you need to put this FA03 from VLAN 1 to VLAN 20. How do we do that? Papasok ka sa interface ng port. Using int FA03 command. Next is, babaguhin mong switch port mode niya into access mode. And then, switch port, access, VLAN. Saan VLAN ba siya? 20. After that, pag nag-do show VLAN ulit tayo, yung port FA03, nasa loob na siya ng VLAN 20. Ngayon, kung kanina, nakakapag-ping sila, ngayon hindi na magpiping yan. Failed na siya. Bakit? They are on a different LAN. So, hindi na siya basta magpiping. Unless, itong isang to, sasali sa VLAN na yon. Let's try. FA02, sabi niya. Sasama ko yung FA02 sa VLAN na yon. So, int FA02, switch port, mode, access, switch port, access, VLAN 20. Ayan, sabi niya, oh, VLAN 20 na rin ako. So, dapat, magkasama na ulit tayo sa LAN. So pagka nag-ping ako, successful na ulit siya. Kasi they are on a same VLAN, same LAN. Diba? So yun yung purpose niya. So halimbawa may isa ka pa ditong VLAN, iba naman. Ibang VLAN naman yan. So ito wala tong kinalaman sa command. Yung bilog na to for visual purposes lang na ibang VLAN na siya. So let's say VLAN 10, this is port 4 and 01. Gawa ulit tayo. Int FA0, VLAN 10, VLAN, exit muna pala, VLAN 10. Name, faculty, sabihin natin. Exit. And then int FA04, tama ba? Yeah, 4 and 1. Ayan. Switch port mode access, switch port access VLAN 10. I want it to be part of VLAN 10. And int FA01, switch port mode, same, access, switch port access VLAN 10. Now, pag nag-do show VLAN tayo, nandiyan na rin yung VLAN 10, port FA01 and 04. Diba? So, dapat sila lang din yung magkikita. Ayan. Sorry, wala atang IP tong isa. Ayan. Ano bang IP nito? 30.10. So, gawin natin tong 30.40. Ayan. So, ngayon, successful, di ba? Nagkikita sila kasi they are on the same VLAN. Pag VLAN 10 to VLAN 20, failed. Because they are on a different VLAN. So, parang different network na rin sila. Pero pwede natin silang gawa ng paraan para mag-meet. Ito yung next topic natin, which is yung Inter-VLAN. So, i-forward ko na. Ito, na-discuss ko na rin to. So, using the show VLAN command. Ayan. So, ito naman, yung trunk link, in case naman na may isa pang switch. Let's delete this. Diba? Yan. Gawa pa ako ng isa pang switch. Tapos may dalawang PC na part ng VLAN. Yeah. Na part ng VLAN 20 and 10 din. Ayan. So let's say this is for VLAN 10, tapos itong isa dito sa kabila, VLAN 20. Ayan. Fast forward natin, 20 to ito 10. Let's configure, lagyan natin ng network muna. IP address. So natapos tayo sa 40. 192.168.30.50. Ito C60. 30.60. 5.5.5.0. Ayan. So, ngayon, magkikita pa sila because they are failed. Tama ba? Yung una pala yun. Ito. Magkikita pa sila because they are on the same VLAN, VLAN 1. Ngayon, si FA02, enable, configure terminal. VLAN 10, gawa muna tayo. VLAN 10. Name is, ano nga ang 10? Faculty. And VLAN 20, name, student. Ayan. Si int FA02, this link is part of VLAN 10. Switch port mode access, switch port access VLAN 10. Next is yung int FA01, itong isa. It's part of VLAN 20. switch port mode access, switch port access VLAN 20. To show VLAN, lalabas dyan, meron na tayo. VLAN 10, faculty, student, ayan. Okay na siya. Yung ports niya, nasa tamang VLAN na. Pag pining natin, it should be failed kasi different na ng VLANs. So parang ganyan na yung itsura niya ngayon. But if we try to ping this, failed siya. Kasi wala silang trunk link na configured kasi magkaibang switch to. Gets? Kailangan natin itong link na to gawing trunk link. How? So this is 03 and 05. Dito muna tayo sa isang to. Int FA03. You put it as switch port mode, trunk. Ayan. So trunk link na siya. Switch port, trunk, allowed VLAN is 10 and 20. Ayan. Wala muna akong ginawang native VLAN. So yung command mo doon, gagawin mo rin dito sa FA05. Int FA05, mali, 05, switch port, switch port mode, trunk, switch port, trunk, ano yung allowed na tumakbo sa trunk mo? Allowed VLAN 10 and 20. After that, fast forward, delete, let's try, 10 to 10, successful. Next, 20 to 20, successful. Diba? So yun yung VLAN trunking natin. So it allows you na magkita, single LAN lang siya, diba? Tapos similar addresses, similar network. Supposed to be dapat magkikita silang lahat. So kung gusto mo sila maghiwalay, dapat gawan mo sila ng ibang network. Pero para mas tipid, para mas madali, you can use your own switch and create a VLAN. Ayan. Yun po yung purpose ng VLAN natin. So Inter-VLAN Routing. So paano daw magkikita yung dalawang VLAN na magkaiba? Diba? Magkaibang VLAN to, ayaw magkita. Pwede siya magkita if we will use a router. So for the Inter-VLAN routing, we have three different options with three options: legacy, router on a stick, and layer 3 switching. So since very limited na yung time, I choose the router on a stick lang na Inter-VLAN routing. So the idea on this is you create a VLAN tags. Ayan. So, gagamit ka ng router interface. It's better, I think, kung dito ko na lang siya explain sa packet tracer. So, I will just delete ito. Mag-focus tayo dito sa dalawang to. Ayusin ko lang po ang ating workplace. Ayan. Delete na natin tong hub. Ayan. So, ito, magkabukod na VLAN siya. Diba? So, para magkita sila, we need a router. So, I'll use a 2900 series of router. And since we're gonna use a router on a stick, magko-connect tayo ng connection FA05 to G00, which is, it should be a trunk link. Kailangan ma-convert mo to into a trunk. Ang alam ko yung port 05 is trunk link na siya kanina. Ito, trunk link na siya. So, ang gagawin na lang natin is to configure this one. Pag-iibahin ko lang yung network natin. Gawin ko tong 40. Kailangan kasi sila magkaiba ng network. Kasi magkaiba sila ng default gateway na gagamitin. 40.1, 192.168.40.1. Ayan. So ito, sila pa rin yung 30. 192.168.30.1. And 192.168.30.1. Ayan. So you configure this router itong G00 as the default gateway for your VLANs. Dalawa yung VLAN. So, kaya gagamit tayo ng sub-interfacing. So, no, enable, configure terminal, host R1, or short for host name, int G00, diretso na tayo, wag na natin ilagay yung mga house rules. Int G00, and then, what do you call this? No shutdown. Yan. So, hindi natin pwedeng ilagay dun sa buong G00 yung IP kasi dalawang default gateway, di ba? Bali, magkakaroon tayo ng dalawang default gateway dyan. 192.168.30.1 for VLAN 10 and 192.168.40.1 for VLAN 20. Tama ba? Di ba? So, magkakaroon tayo ng dalawang default IP address or default gateway, pero isa lang yung link. So, tawag doon is sub-interfacing. Int G00.10. This is for VLAN 10. Ayan. Pumasok tayo sa sub-interfacing. Next, hindi ka makakapaglagay agad ng IP address unless baguhin mo muna yung encapsulation. Using encapsulation.1q para malagyan mo siya ng tagging. And then, followed by your VLAN ID, which is 10. Lagay mo yung IP address 192.168.30.1, 255.255.255.0. And after that, sa kabila naman na interface int G00.20 naman. Encapsulation.1q VLAN 20. IP address is 192.168.40.1, 255.255.255.0. So exit. Hindi mo na siya ino-no-shot kasi ang mino-shot na natin yung G00. Ito. Now let's try if they can ping each other now. Failed and successful, di ba? Pag sinimulate natin siya, ganito yung itsura niyan. Papadala ni switch, sabi ni switch, hindi ibang VLAN yan, pero pwede kita ipadala kay router. So papadala niya kay router using a default default gateway, and then si router ibabalik niya. So paangat ulit kay router, pabalik sa destination. And so that's our inter-VLAN routing. Yep. Ayan. So, yun po yung inter-VLAN routing. So, ito na din yan, yung preparation, nagawa na natin. So, yun na tayo sa packet tracer demo. So, I created this packet tracer na ito na yung inter-VLAN. So, may VLAN na siya. Ang gawin na lang natin ngayon is this one, I created this server na as a HTTP server. Yan. Meron siyang, kinopy ko yung Google na HTML file. So, sinave ko siya dito. And then, ang IP niya is 10.20.20.2. Ayan. So ito, I've already configured this router with routing. Yung default route. Napakita ko na naman kanina. So, do show run. Ayan. Ayan, ito. May default route siya. Ang ka-point-to-point niya is ito. Ayan. Cluster na yan. So, ang IP ng server natin, sulat ko lang, 20.20.20.2. Ayan. Ang goal natin is itong PC na to, di ba? Yung PC na to ay may connection na siya. Pagka nagpunta tayo sa web browser, that's No. 20.20.20.2. Diba? Ito na yan. Hindi lang niya nakopy yung image. Pero this is the Google na kinopy ko. Ito yung HTML file ng Google na kinopy ko. So, ibig sabihin, na-access ko ang web server. Ngayon, ang goal natin is for this device to access the web server. Paano natin gagawin yon? Kahit hindi na natin gagalawin to as VLAN, kasi na-discuss na natin yung VLAN, our goal is to connect this router to this router using RIP version 2 commands. And then we propagate this default route papunta dito para kahit yung device na to makapag-access rin siya sa internet natin dun sa browser. So how do we do that? First is ito kasi pre-configured na. Ito na lang yung router na i-configure natin. We configure this interface with this address 192.168.20.1 and also this one, gig 00, ang IP niya 30.30.30.2. Ito din, hindi pa siya configured. Unahin na natin tong router na to. So I've already renamed it enable configure terminal. So interface gigabit 01. Ito yun. So IP address niya is 30.30.30.0/24. Therefore siya ay 255.255.255.0. And then 30.0 pala nalagay ko. .1 dapat. No shutdown. Ayan. Bit. So, na-no shut ko na siya, pero naka-red pa rin. Kasi, kailangan yung kabilang link is naka-on din. Ayan. Enable, configure terminal, int G00. Ayan. Ito naman yon. Ito po yon. Interface, IP address 30.30.30.2. 30.30.30.2, 255.255.255.0, and then no shutdown. Diba? After nun, automatic nag-green na silang dalawa. Therefore, okay na yung link. Next is this link naman, yung default gateway ng PC na to. So how do we do that? Pasok tayo ng int G01, IP address 192.168.20.1, base here, 20.1, 255.255.255.0, and no shutdown. Ayan, okay na. Now, yung PC, lagyan natin ng address 192.168.20.10, 192.168.20.10, and the default gateway .20.1. Ito yon. So dapat the router, the PC can ping the router. Ayan. So ngayon, if we check PC to PC, malayo, so failed. Bakit? Ano ba yung IP nito? 192.168.10.10. Pag tiningnan natin sa simulation, diba, i-forward niya. Pagdating kay router, namula na siya, X na. Bakit? Pag tiningnan natin yung IP route ng router, do show IP route, yung routing table, sabi ni router, kanino mo ba gustong pumunta? Kay 10.10. Siyempre, titingnan ni router yung routing table niya. Sorry, nag-close. Do I have a valid route to 192.168.10.10? Wala. Tama? 10.20. 20.0, 30.0, wala. Therefore, hindi niya alam kung paano pumunta doon. Kaya, ibabalik niya. So, failed. So, ang goal natin is for this router and this router to configure RIP para makapag-usap yung dalawang yon. So, how do we do that? So, first, let's configure this router. So, may technique naman dyan. So, first, router RIP, version 2, and then you use the do show IP route connected. Kung ano yung entries na lumabas, yun lang yung ina-network mo. Network 30.30.30.0 and network 192.168.20.0. Okay na ba? So, ngayon pwede na. Pag tiningnan natin sa simulate, abangan natin yung router 1, magsisend na siya ng WIP updates. Every 30 seconds kasi. Kaya matagal. So, medyo magpa-fast forward tayo. Ayan, nag-send na siya. WIP. Finorward niya yung broadcast. Nakarating kay R1. Hindi ni-receive ni R1. Bakit? Dahil hindi pa siya configured as RIP. Ngayon, we will configure R1 with RIP. So, router RIP, version 2, do show IP route connected. So, ayaw mong i-propagate yung 10.10 kasi ito yung default route mo. So, ito lang dalawa. Wait. So, network 30.30.30.0 and network 192.168.10.0. Ayan. So, meron na tayo na route. Ngayon, if we check, kanina ba tayo huling nag-IP route? Ito. Sa huling IP route, C at L lang ang nakalagay. Ngayon, since nag-configure na tayo ng RIP, dapat may makikita na tayo dito na R. Pag ulit tayo. Do show IP route. Ayan, meron ng R. So, alam na niya kung paano pumunta kay 10 at 20 zero network. Ito yon. So, 20 kasi ito. 20. Ayan. So, alam na niya kung paano pumunta dito. Di ba? Meron na siyang route. Kita natin. Ito. 10.0/24. Administrative distance, 120. Ilang hop? Ito yung metric 1. Kasi R to dito. So, that's 1 hop. Ito yung next hop address, timestamp, and exit interface. Ayan. So, if we try to simulate now, ayan. Tingnan natin. So, R1, sabi ni R1, kanino mo gustong pumunta? Kay 20.0 network. Teka, do show IP route muna tayo. Sabi, alam ko yan, kay 20.0 network, dito yan. Dito ka dumaan kay G00. Dito ka babagsak. G01 pala. So, forward niya. Tapos na-receive ni router, nag-send ng reply, nakarating, successful. Diba? Successful na siya. So, okay na yung RIP natin. Nagko-converge na sila, nagmi-meet na. Ngayon, isa pa sa mga goal natin is kailangan ito makapag-browse. Itong PC na to. O, paano? Ayan o, hindi niya ma-browse. Pero yung ito, nababrowse niya. So, syempre, kasi sila yung connected dito sa internet. Diba? Ngayon, the only command na gagamitin is yung R1. Kasi siya yung R1 lang yung connected dito. So, siya yung may kailangan mag-propagate nung default route niya. So, paano yon? Router RIP. So, version 2, baka kasi malimutan. And then, default information originate. After that, yung R1, magkakaroon siya ng R asterisk. Ayan. Ibig sabihin, nagkaroon siya ng R asterisk na kapag hindi niya alam yung ipapadala or yung sender or yung destination, dito niya ipapadala yan kay G00. Ito. Ngayon, let's try. Let's reload. Ayan. So, napuntahan na niya yung web browser. So, if we try to ping server, ayan. Sa simulation, delete muna natin ulit. Patunay. Ayan. So, forward. So, makakarating na siya. So, mapo-forward na siya sa internet and makakabalik na siya. Diba? So, may internet na siya. Connection. And, where's that? That's it. Q&A na po.
Thank you very much, Sir Erwin,
Sige,
for
Miss.
imparting your knowledge and your expertise on this topic and providing a substantial and essential information about routing and switching. So, can I share also my screen? So a gentle reminder lang po for our participants, you need to accomplish the post-evaluation form later, and we have a short quiz incorporated to it. The passing score is 7, and the deadline of submission is today, August 6, 8 p.m. So let's proceed with the Q&A. Erwin?
Yes po, ma'am.
Papa, you have access to our Q&A, list of Q&A?
Yes po. Parang yung mga questions nila is about sa PowerPoints, sa slides. So yung slides po ay may link na pinost si Ma'am Chris kung saan nyo po mada-download yung yung slides po natin for this webinar.
Okay.
So for the Cisco Packet Tracer naman po, na-download ko siya sa mismong website ng Cisco Network Academy. So pwede naman po kayong mag-register doon. Should I na lang po, present ko para mapakita ko sa kanila yung ayan. So pwede po kayong mag-register or kung wala pa po kayong account, gmail.com. So, meron po ditong tab yung Cisco wherein you can download yung latest. So, si resources, Packet Tracer resources. Ayan. And then, Packet Tracer download page. And dito nyo po mada-download yung latest version ng Packet Tracer, which is yung version 3.0, 7.3.0 for Linux, Mac OS. Pwede rin po siya sa mobile and yung Windows na 64 and 32 bits. If in case po, may mga Packet Tracer file po kasi, halimbawa may gusto kayong i-open na file na dati pa siya na file na hindi na siya ma-open sa bagong Packet Tracer, you can download the old versions or previous versions ng Packet Tracer dito naman po sa baba. Ayan. So ngayon po kasi yung Packet Tracer, nire-require na siya or advisable sa kanya na pag ginamit mo siya, you also log in your account. Your Cisco Academy account for kapag ka nag-open ka ng Packet Tracer. Ayun po. Yun pong mga net flow and network monitoring tools. So hindi po kasi siya sakop nung routing and switching. Mas more on dun po siya sa network management. Yung pong Packet Tracer files ko na sinave are yung ginamit ko po. I will save it na lang po and then I will also share it dun sa link po na ibibigay nila. Ayan.
Um, are there any other questions from our dear participants?
May nag-ask po ng second code.
The last code will be flashed at the end of this session po. Okay. I think we're done with the Q&A portion. Thank you again, Sir Erwin.
Welcome po, ma'am.
Okay po, we'll be having our class picture now. So for everyone with webcams, please may I invite you to open it now for our class picture. I think Ma'am Riza or Ma'am Jessica will be taking the picture. Okay, so yan. Okay, say cheese, everyone.
Cheese.
Smile. Okay, I think we're done. So at this point, may I call on the provincial head of DICT Batangas for the closing remarks, Ma'am Mary Joy Rivera. Ma'am MJ.
Hello po, good afternoon. Hello po, good afternoon.
Good afternoon. Good afternoon, Ma'am MJ.
Yes, good afternoon
Hello
po.
po.
Good afternoon po.
Hello po. In behalf of
Good
the
afternoon
ICT,
po.
ayan. In behalf of the ICT LC2 and LC2 Free Wi-Fi team, we would like to extend our deepest gratitude to Sir Erwin De Castro for sharing your time and knowledge with us with that very detailed and useful webinar session regarding introduction and switching and routing using Cisco devices. Also to Ma'am Grace Bukad and Batangas State University CICS department. Thank you po. I know this webinar will be of the great help, especially to students. Also to our participants, we really appreciate for taking a few hours of your time to attend our webinar. We will continue to serve and provide webinars for you guys. Again, thank you very much and stay safe, everyone. Thank you po.
Okay, thank you, Ma'am MJ. Again, thank you, Sir Erwin. I'll be flashing the... Okay, let me flash the last slides.